generation of technology, the new generation of information. They bring the future before us. Institut Teknologi 10 November, a place where the spirit of heroism underlies the new generation to research and innovate in technology. The University of Heroes, ITS. ITS is one of the best science and technology universities in Indonesia, which was founded by Dr. Angga in 1957. In every step, ITS focuses in advancing education, research, management, and community service. As an incorporated public university, ITS has been able to manage autonomously the policy of academics, organizations, finance, students' affairs, human resources, facilities, operational, and infrastructure.
In the spirit of Indonesian heroes, during the battle in the 10th of November 1945, ITS always makes efforts to be the best in education, research, and community services, especially in the fields of industry and maritime. ITS also actively contributes to the nation development, and in the future, ITS will become an entrepreneurial university with world-class reputation.
ITS has many achievements. Both national and international achievements prove that ITS keeps growing and gives the best contribution to the nation of Indonesia. ITS is a place for new hopes to grow. An ideal environment for the new generation to flourish in 3 strategic locations within the industrial city of Surabaya. As a smart eco-campus, ITS maintains harmony between technological advances and the sustainability of the surrounding ecosystem. ITS has 7 faculties with prospective scientific fields, including Scientics, INSIS, Vocation, Creatis, Martech, Electics, Plan. ITS is a space for the new generation who are hungry for knowledge because it provides a wide range of references in both physical and digital form. ITS makes it easier for the new generation to access information by providing flexible classes. ITS keeps moving forward in facing future challenges by providing the best facilities for the new generation's activities. The facilities support both spiritual and physical needs. ITS also provides research facilities in the ITS Science Technopark, including ICT and robotics, automotive, maritime, and creative industries. Therefore, the excellent generations from ITS will emerge and make history. ITS is a space for the new generation to express themselves. ITS is a place where the new generation learns new things and finds their purpose. ITS has become a place where the new generations that carry the future will be born.
ITS is a campus of science and technology, which focuses on the research and innovation, presenting technology for prosperity.
With a spirit of heroism, ITS brings the future before us. ITS, the University of Heroes. The world keeps evolving. The times keep changing. The new generation of technology. The new generation of information. They bring the future before us. Institut Teknologi 10 November, a place where the spirit of heroism underlies the new generation to research and innovate in technology. The University of Heroes, ITS. ITS is one of the best science and technology universities in Indonesia, which was founded by Dr. Angga in 1957. In every step, ITS focuses in advancing education, research, management, and community service. As an incorporated public university, ITS has been able to manage autonomously the policy of academics, organizations, finance, students' affairs, human resources, facilities, operational, and infrastructure.
In the spirit of Indonesian heroes, during the battle in the 10th of November 1945, ITS always makes efforts to be the best in education, research, and community services, especially in the fields of industry and maritime. ITS also actively contributes to the nation development, and in the future, ITS will become an entrepreneurial university with world-class reputation.
ITS has many achievements. Both national and international achievements prove that ITS keeps growing and gives the best contribution to the nation of Indonesia. ITS is a place for new hopes to grow. An ideal environment for the new generation to flourish in 3 strategic locations within the industrial city of Surabaya. As As a smart eco-campus, ITS maintains harmony between technological advances and the sustainability of the surrounding ecosystem. ITS has 7 faculties with prospective scientific fields, including Scientics, INSYS, Vocation, Creatives, MarTech, Electics, SIFPlan. ITS is a space for the new generation who are hungry for knowledge because it provides a wide range of references in both physical and digital form. ITS makes it easier for the new generation to access information by providing flexible classes. ITS keeps moving forward in facing future challenges by providing the best facilities for the new generation's activities. The facilities support both spiritual and physical needs. ITS also provides research facilities in the ITS Science Technopark, including ICT and robotics, automotive, maritime, and creative industries. Therefore, the excellent generations from ITS will emerge and make history. ITS is a space for the new generation to express themselves. ITS is a place where the new generation learns new things and finds their purpose. ITS has become a place where the new generations that carry the future will be born.
ITS is a campus of science and technology, which focuses on the research and innovation, presenting technology for prosperity.
With a spirit of heroism, ITS brings the future before us. ITS, the University of Heroes.
Distinguished guests, ladies and gentlemen, before we start commence the program, and here are the following webinar protocol. For each participant ID, please use your real name following with your origin of institution. All of participants are expected to mute the audio and only unmute the video during the event. We cordially invite you to take your own firm and comfort seat in your own room, and please avoid the backlight. Make sure that you have a good and stable internet connection. If you have an earphone or headset, we recommend you to use it so that your voice can clearly and loudly to be heard. During the Q&A discussion session, all participants, please use the chat box to deliver the questions. Thank you for your cooperation and consideration.
Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, ladies and gentlemen. Welcome to the guest lecture series on SDGs today, Tuesday, 7 September 2021. I am Nabila from ITS Global Engagement, and I will be your master of ceremony this afternoon. Thank you for joining our guest lecture series on SDGs today. Before we start our agenda, let me inform you of some rules for the event. First, please adjust your name or ID screen using format name_campus. Second, during the lecture, please turn off your microphone and only turn on the microphone when the moderators give the chance. Third, please fill your attendance at bit.ly/GLS_attendance. Our committee also sent the attendance link in the Zoom chat room. And for participants who wish to get an e-certificate and stamp for it, please fill the attendance 15 minutes after the session starts. Fourth, participants who wish to ask questions during the question and answer session, please send your question to bit.ly/GLS_Q&A. The link for the Q&A session is also listed in the chat room as well. Or you can also ask directly by clicking the raise hand feature. Okay, so today's GLS on SDGs will discuss about goal number 11, about sustainable cities and communities with two amazing experts who have joined with us today. Let me greet our speakers first. To Dr. Agnes Tuti Rumiati from SDG Center ITS. Hello, Dr. Agnes.
Hello, Assalamualaikum.
Waalaikumsalam. How are you, doctor?
Yeah, I'm fine today.
Yeah, thank you for joining with us.
You're welcome.
And the other speaker, Dr. Uswah Khairuddin from Malaysia Japan International Institute of Technology, University Technology Malaysia. How are you, Dr. Uswah?
Hello, I'm good, thank you.
Yeah, thank you, Dr. Uswah. And as amazing as our speakers, Dr. Astria Nur Irfansyah from ITS, who will be our moderator today. Hello, Dr. Irfan.
Hi, I'm Nabila. Thank you.
Yeah, thank you to Dr. Agnes, Dr. Uswah, and also Dr. Irfan. I guess everyone's already excited to have the discussion today. So the first topic is mapping of SDGs. What is SDGs mapping and how to apply it? That will be delivered by Dr. Agnes Tuti Rumiati from SDG Center ITS. And the next topic is entitled Turbocharger Design Optimization. That will be delivered by Dr. Uswah Khairuddin from Malaysia Japan International Institute of Technology, University Technology Malaysia. This lecture will be moderated by Dr. Astria Nur Irfansyah. And before we start our agenda, allow me to deliver our schedule today as follows. First, the opening. Second, introduction to moderator and speaker. Third, lecture session. And fourth, we will have the Q&A session. And after the discussion, we will have certificate awarding and also closing. Okay, now before we proceed to the next agenda, let me introduce our moderator's profile. Yeah, so this is our moderator today, Dr. Astria Nur Irfansyah, or we can call him as Dr. Irfan. Dr. Irfan is a lecturer and researcher at Department of Electrical Engineering, ITS Surabaya. And he is also our senior manager for international partnership at ITS Global Engagement. And Dr. Astria Nur Irfansyah also got his PhD at the University of New South Wales, Australia. Dr. Astria Nur Irfansyah also acts as Vice Secretary at IEEE Industrial Electronic Society Indonesia Chapter. and he was also lab demonstrator at UNSW Australia. His research interests include microelectronics, embedded systems, and UAV. To Dr. Irfan, without further ado, I give the microphone to you.
Thank you very much, Ms. Nabila, for that really kind introduction. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Good afternoon, and I hope everyone is well. Thank you for attending our GLS SDGs virtual guest lecture program. Today we will be focusing on SDG number 11, Sustainable Cities and Development. Before that, I'll reintroduce myself. My name is Irfan. I will be serving as the moderator for today. And we are pleased to have with us two distinguished speakers. Committee, can you please show the profile of the speakers? So our first speaker will be Dr. Agnes Tuti Rumiati, MSc. She is our faculty member at ITS Surabaya. She is the senior lecturer in Department of Statistics. Assalamualaikum, Bu Agnes Tuti. Good afternoon.
Waalaikumsalam. Good afternoon, Pak Irfan.
Thank you, Ibu, for becoming our speaker today. She is also the director of the ITS SDGs Center. Previously, she was the Institute Secretary of ITS, and in between 2015 and 2020, she became team leader of Indonesia School Quality Assurance, Indonesia Ministry of Education and Culture. In 2000 until 2008, she also became head of the Community Service Unit at ITS. She received her doctoral degree of statistics from IPB, Bogor Agricultural University in 2012, Masters of Science in Statistics, University of Sheffield, United Kingdom in 1996, and Bachelor of Science in Mathematics, Institute Technology, 10 November in 1982. Her expertise is social mapping, community development and partnership, program development and management, corporate social responsibilities, and good governance. Today, she will be presenting mapping of SDGs. What is SDGs mapping and how to apply it? And the next speaker will be Dr. Uswah Khairuddin. I will read her profile later on. So first, we will listen to the first presentation from Dr. Agnes Tuti Rumiati for about maybe 35 to 40 minutes, and then we will move on to the second presentation, and then we will have a discussion and question and answers, if you may. All right, so without further ado, please, Bu Agnes Tuti, you may start your presentation. Thank you.
Thank you. Thank you, Pak Irfan. Assalamualaikum warahmatullahi wabarakatuh. Hello, everybody. Good afternoon. I'm happy to be here today. I'm happy to be here, discuss with you, all of you, especially for Dr. Uswah Khairuddin. Today, I would like to discuss about mapping of SDG. What is the SDG mapping and how to apply it? And before, allow me to explain first about SDG ITS, or we call Community Engagement Center for Sustainable Development Goals. The SDG ITS is established in 2020, so just last year, Bu Uswah. Just 1 year, more than 1 year, The establishment of the SDG Center is the real step for ITS to support the acceleration of IDG, especially for eastern part of Indonesia. So this is our target, SDG Center of ITS. This is the eastern part of Indonesia. This is our vision and mission, and this is our approach. So we develop methodology and piloting of programs, yeah, that can be applied in village, yeah, in village. And after that, we want to duplicate to other location. And also, we train village people for data collection, planning, program arrangement, implementation, and monitoring and evaluation, of course, and also conducting policy review. And we also try to make a model can be duplicated to another location. So I just want to say that we focus on village. Yeah, we focus on village. Yeah, this is not mean that we don't want to help the local government, city or agency, but in this case we mostly working on village. And internally, we also have good collaboration with all lecturers in ITS or all researchers in ITS or other units with different field of knowledge in ITS to train and facilitate the government and community to achieve village SDG. So I would like to explain later that Indonesia have a special SDG target and village level. We call SDG village SDG. Yeah, and this is our partner, national and international. So we have experience with ILO project, UNESCO, and Australia Global Alumni or AGS, and also in national level, we also have networking with Ministry of Education and Culture, Bureau Pusat of Statistics, also Bappenas. Bappenas is Ministry of National Planning, and also with local government, province level, and kabupaten or city level. Okay, so as we know, SDG global goals have 17 goals. And of course, ITS cannot think all of to achieve all of the goals. Yeah, it's depend on our interests, of course. Yeah, and in Indonesia, is if you see from this map, Indonesia is very big. Maybe if I don't know if we compare to Malaysia, yeah, I don't know how many times. This is Indonesia is very big, and we have already 270,000, yeah, more than 270,000 million people. So it's very big population, and number of province is 34, sorry, and also number of city and district is 514, and number of village is 70, almost than 75 villages, and number of wards is 8 almost 0.5, yeah, wards, yeah, kelurahan I mean. So if we think about SDG here, we can imagine that this is have to apply, have to implement it in this big area and with very big population also, and also two numbers of villages, 75 villages and 800 8,000.5 words. This is very complicated things, I think. Yeah, so that's why we have to focus in this area. Yeah, in this area. Of course, we need data to know about how the achievement of all area in Indonesia. For example, if we want to know how many city or district can achieve SDG goals, number something. So we need data, of course. And also, if we want to know how is achievement of the SDG in the village level, so we have to develop data to measure about the achievement of the SDG target, of course. So data is the data makes possible to highlight the issue. Yeah, highlight issue that would otherwise risk having little visibility. So if you want to know how many people in Indonesia do not access to clean water sources, yeah. So you need to talk about it, and this is why we think, yeah, and SDG is a think that the mapping of the condition of achievement of SDG is very important. Yeah, the mapping key indicators is derived from the 17 goals. Of course, yeah, we derive from the 17 goals into indicators and also to many variables to be measured in each area. So this is the why we concern about the SDG mapping. Yeah, actually, Bappenas, yeah, Ministry of National Planning already have a map. They develop roadmap of SDG in Indonesia, and the SDG is carry 5 fundamental principles that balance the economic, social, and environment. So they give name people, planet, prosperity, peace, and partnership. And these 5 basic principles are known with the term 5P, consists of 17 goals, 169 target, and 242 indicators. So all indicators is distributed, yeah. All indicators are distributed in all goals, yeah. So you can see from this table, this is the distribution target and also the indicator. And Bappenas also have a metadata indicator, and the all SDG target and goals are divided into 4 pillars, namely the social development pillar, economic development pillar, the environmental development pillar, and legal and governance development pillar. So this is maybe they want to make easily to see how to achieve the all pillar in Indonesia. And I would like to give you an example how the BPS, the Bappenas make a map. Yeah, for example, for the goal 1, this is about poverty. So the goal 1 is no poverty in Indonesia, of course. But if you see from this graph, the target of SDG goals number 1 in Indonesia is not 0, but the target is 4.33% poverty if Indonesia can success intervention the this problem. But if only using the business as usual, so we only Indonesia only predict can achieve the target only 5.73%. Yeah, so the intervention maybe can make reducing the presentation of the poor people only about 1.4%. Yeah, if you see from this number. And this is an example of this picture is example of the poor people in Indonesia. Yeah, like this. So this is that Indonesia want to get a solution. Yeah, want to have a solution to increase the quality of the people, the poor people. Yeah, and to know the focus area, so BPS and Bappenas, Ministry of National Planning, together with BPS, is make this map. If you see from this map, yeah, we can see that the red color is the location with high percentage of poor people. So mostly is in eastern part of Indonesia, if you see from this map. So Kalimantan, Sumatra, and Java is much better, yeah, than Papua, yeah, if we see from this map. So I just want to say that the map, yeah, the mapping is very, very important to give a picture how the government, local government, can achieve the SDG goals. Yeah, for each goals, of course. And well, what about zero hunger? Yeah, I think this is the same. Yeah, this is the same. If Indonesia success, actually the target is zero. Yeah, zero hunger. So the target is zero. But Indonesia only can set the target 10% for 2030 if Indonesia can give intervention to this case. But if no intervention and using business as usual, we only achieve this target 22.37%. So this is this data give us how the complicated problem to achieve this target. Yeah, also for health and well-being. Yeah, so the target is actually in the 2030 is not zero. Yeah, this is the I think the detail. I think I cannot explain one by one, but you can see from this PowerPoint, so you can see the data in detail. And also for education level, Indonesia still not very good, yeah, especially for literacy, especially for proficiency in reading and math, yeah, and mathematics. Yeah, you see that in reading, yeah, this is much better compared to mathematics, but mathematics is the proficiency of student in mathematics is very, very low. Yeah, this is just give you an example how Indonesia develop a measurement and also how Indonesia make a map about this. Yeah. So this is the condition. Yeah, the map. Yeah, and I think so many data can have to measure, have to analysis, and then uh, uh, transfer to mapping. And Indonesia also now have a we call village SDG. This is actually almost the same with national SDG or global SDG. Yeah, the national SDG have 17 goals, but for the village SDG we have 18 goals. So the Ministry of Village uh, add one goals, the goals 18. Yeah, the one at one goals is the goals 18. Why? Why the government want to measure the village SDG? Because if we see from the structure, yeah, in Indonesia, government structure in Indonesia, village is the center. Village or wards is the center. So above the village we have district and also regency, city, province, and national. So it means that if the SDG can be achieved in the village level, so we also can make sure that the regency or city level can achieve the SDG as well, the SDG target as well. As you know, 91% of Indonesia territory is village territory. Yeah, village territory because we have 70, almost 75 villages in Indonesia. Yeah, 75,000 villages. Meanwhile, the number of wards is only about 8,000 villages, wards. Yeah. So this is 91% territory is village territory. 11 national sustainable development goals are closely related to village territory. Yeah. Meanwhile, the action toward achieving 12 SDG contributed 91% to the achievement of the National Sustainable Development Goals. And 43% of Indonesia population lives in villages. So the goal of sustainable national development is closely related to villagers. And the action toward achieving the 6 SDG in the village contributes 43% to national development. And village SDG are grounding for sustainable development goals or national development goals stated in presidential regulation number 59 at 2020. Village SDG themselves at the 8th point, yeah, namely dynamic village development and adaptive village culture. So this is the 18 goals, yeah. 18 goals. This is the dynamic village institution and adaptive culture. So this why the Ministry of Village add one goals here because yeah they want to the Ministry of Village is one village development want to appreciate the existence of the diversity and religion, culture, language, custom, and so on of Indonesia people and capture the local wisdom of community and productive village institution in order to survive the develop. So why the village Ministry of Village Development at one goals we call dynamic village institution and adaptive culture. And so after I learned about this, yeah, I think that we have to measure the achievement of SDG. The target, can we achieve the target or not, and why, and how? Yeah. So, and if we have capture, yeah, we can map the condition, the initial condition of the village. So we can know the initial condition, and then we of course we want to know after intervention, what is happened after intervention. Of course, we want to know after 1 year after 1 year intervention, what happened. Yeah, we hope there is a increasing, yeah, the quality of all of 17 or 18 goals. Yeah, if in a village level, we want to know how the 18 goals each year, year by year. So we know the increasing of the condition of the village. And village have to have the program using the cycle. Yeah, if you see from the cycle, the village have to make a village self-evaluation. So this is a village self-evaluation year by year. And this is using to make a planning, implementation, and monitoring, and also getting the result, so the improvement result. So that's why we need a map. Yeah, we need to follow the improvement of achieving SDG in one area. Yeah, in this case in village area. So this is why we think that mapping is very, very important. And in village level, the Ministry of Village Development try to make 1, 2, 3, 4, 5, 6, 7, 8, yeah, 7, 8 classification. This is a village without poverty and hunger, and then economic village grow evenly, and health care village, and so on. So they just want to grouping, yeah, make classification about the target of SDG 18 SDG into 8 dimension, yeah. And the indicator of village SDG is about 220 indicators. 210 is coming from global or national SDG, and 12 indicators is coming from the 18 village SDG. Yeah. So this is the new indicator, because we implemented the village SDG. And if you see the indicators, it's like this. Yeah, for goal number 1, for example, we have 5 indicators. Yeah, so we have to count how many poor people in this village. Yeah, the target is poverty rate reach 0%. Yeah, in village level. And percentage of village resident participating in the SIGSN in the health and employment sector is reached 100%, and so on. So if you see from each goal, we have to measure one by one indicator. Yeah, this is I think this is not very easy, yeah, to implement, because not all data is available in the village level. So yeah, this is very hard effort to have all information about the indicator of its goals. Yeah, I just want to show you that the indicator is quite complicated. Yeah, so this is have to give explanation first to the village staff. Yeah, how to get the data and how to measure and so on, and also how to upload this data. We have a Ministry of Village Development already developed application for this. Yeah, the name of application is SID. Yeah, SID is D is desa, ya, SID Sistem Informasi Desa. So the all village in Indonesia have to upload all information about SDG and its village. Yeah, this is of course big effort. Yeah, because they have to know what is the meaning of each indicator and what we can have the information about this indicator. Means that we have to get the data and so on, yeah, and then upload in the SID. This is the SID, Sistem Informasi Desa. Yeah, so actually the village also can use this for their own objective. Yeah, for example, they maybe the village want to make a planning, so they can also use this data not only for national level. Yeah, and SDG ITS already try to use the data from national data. Yeah, and this data is coming from each city and regency, of course. So, and SDG ITS try to make a mapping also for village SDG mapping. This is the example. We already make a village SDG mapping in Sidoarjo district. This is just for piloting. So with the same way, with the same methodology, I think all Indonesia city and regency can also make the same using the same methodology. And in Indonesia, Ministry of Village Development haven't made this mapping for village mapping yet. So this is I would like to give to the Ministry of Village Development to use the same way or to use the same methodology. And this is the example for clustering economic sector. For example, we have so many variables here, and then the data is coming from SID or from another resources, and then we use mapping statistic for mapping, clustering, yeah, make cluster analysis, and then we try to make like this. So I think the local government like Regency of Sidoarjo, government from Regency of Sidoarjo can use this map to focusing the in which village in which village have to be improved in economic sector using this information. And also this is the another example, in clustering result on village SDG in Sidoarjo. So we have many sector here: infrastructure, village without gap, environmental, partnership development, and so on. I think this is the end of my presentation that I just would like to give you a brief explanation about the mapping and how to make this map and how to apply. I think this is very important to government to have a map because they want to have a clear clear information about the condition in each indicator, and mapping can give the information about the location which is still have a problem in this indicator. Pak Irfan, I think I can finish this presentation. Thank you.
Thank you very much, Dr. Agnes Tuti. Let's give an applause to the presentation delivered by Dr. Agnes Tuti. Thank you very much, Ibu. So thank you for the very clear presentation, Bu Agnes Tuti. So you have presented the importance of mapping of SDGs indicator in Indonesia with ICT, data collection, statistics. So I hope we now know a better overview of the SDGs targets set by our government, the Indonesian ministry, and the measurement, how is it going to be done, and how the maps are made. So just as a reminder for all participants, if you have any questions to Dr. Agnes Tuti, you can write or type your questions in the link provided by the committee in the chat box. Or you can also raise your hand later when it's in the Q&A session. All right, so moving on to the next presentation, let us welcome our distinguished speaker, Dr. Uswah Khairuddin. Assalamualaikum, Dr. Uswah Khairuddin.
Waalaikumsalam. I'm good, thank you.
Thank you, Doctor. So let me, before we read the profile of Dr. Uswah Khairuddin, so let me introduce the title of her presentation. She'll be talking about turbocharger design optimization. So maybe some of you may be wondering, the second topic sound maybe rather technical, so about engine design. So I got the chance to have a sneak peek into the presentation from Dr. Uswah, and so what I learned is as we cannot underestimate the importance of engine design and its optimization, because energy use in transportation contributes to 17%. If I'm not mistaken, sorry if I got it wrong, Dr. Uswah Khairuddin. So 70% global greenhouse gas emission is from transportation. So if this technology work, it will be good for us, right? So she will be talking about that and also other supporting technologies for the turbocharger design optimization. So that's in an engine, apparently, in cars or automotive. So I guess there's this overlap, from our two speakers today in terms of technologies. I think that's the overlapping thing. Technology can be used to support SDGs, right? Dr. Agnes Tuti already presented the use of measurement technologies, data analytics, and mapping, and technologies to measure the achievement of SDGs indicators. So let me now read the profile of Dr. Uswah Khairuddin. She is currently senior lecturer for the Department of Mechanical Precision Engineering in Malaysia, Japan International Institute of Technology, MJIT, at UTM, University of Technology Malaysia. Between 2008 to 2013, she was tutor of Electrical and Mechanical Engineering Department at UTM Razak School of Engineering and Advanced Technology. She received her PhD in Mechanical Engineering, Diploma of PhD in Mechanical Engineering from Imperial College London, 2017, Master of Electrical Engineering in UTM, Malaysia, 2013, and Bachelor of Engineering and in Mechatronics, International Islamic University, Malaysia, in 2007. Her research interest is artificial intelligence, machine learning, machine vision, application and design optimization and workflow, low carbon transport, and automotive turbocharging. So, Dr. Uswah Khairuddin, you may start your presentation between 35 to 40 minutes, and then we will continue with questions and answers. Thank you. Doctor, please, you can start.
All right, thank you very much for the kind introduction, Dr. Irfan. All right, so thank you very much for inviting me to this lecture series, and I'm really excited to share my work with you guys. And as Dr. Irfan have said before, like my background is mainly artificial intelligence, but I also work in multidisciplinary application, and one of them is in low carbon transport technology. And today, I would like to present one of my projects, which is the turbocharger design optimization. And this is related to the SDG number 11, Sustainable Cities and Communities. Okay. However, as Dr. Agnes has presented before this, like some of the SDGs are interrelated to each other. And for environment, of course, it is related to more than one SDG. Okay. Okay, for example, this topic, of course, I said that it is related to SDG 11. However, it is also correlated to SDG number 7, affordable and clean energy, number 12, responsible consumption, and then number 13, climate action. And you will see why from this presentation. And don't have to worry too much. This presentation is not that technical. I just put some technical bits in it. So this is how I'm going to present today. So I'm going to self-introduce myself, but only a little bit because Dr. Irfan has introduced a lot of my background. And then motivation behind the project and introduction about turbocharger and evolutionary algorithm, which is artificial intelligence algorithm. And then how these two, number 3 and 4, is combined to do turbocharger optimization and the overall of low carbon transport research. All right, so as you guys know, I'm from UTM, and there's a faculty called Malaysia-Japan International Institute of Technology, which is a government-to-government project between Malaysia and Japan government. And we have mechanical department, electrical department, chemical department inside that faculty. So I'm working with the mechanical precision department. Okay, my education, as you can see, my background is a bit multidisciplinary. I'm from mechatronics engineering, and then I did masters in electrical engineering, which is in artificial intelligence, and then I went for mechanical engineering PhD. And in UTM, I am a member of Center for Artificial Intelligence and Robotics, and I'm also a staff under MJIT faculty, and in Imperial. My colleague from UTM has developed this low carbon transport center in cooperation with Imperial College. So I'm associate member of this research center as well. And the motivation behind this project is actually global warming. So everybody's talking global warming nowadays. And even in Kuala Lumpur, just last month, we had a very cold weather. The temperature dropped until 27 degrees Celsius, which is very cold for Malaysia weather. Okay. And okay, so what is it? What is global warming? So the term global warming comes from the word itself. So how the world globally gets warmer. So the ocean temperature is getting warmer every year. So they are looking at the average of water temperature in the ocean, and every year the average is getting higher. All right, and the Earth temperature is rising as a result. You can see the temperature is rising. And the effects of global warming is huge. Okay, we have melting glaciers and we have rising sea levels. We have infectious disease outbreak because of this. And then there's disruption of habitat, extinction, and you can see from around the world there's forest fire and flood everywhere. So the habitat got disrupted, and then we have all of these natural disasters, heat waves, heavy rain, and flooding. And how did it happen? So if you look at the theory, how did it happen? So we receive solar radiation from sun. All right, so the sun passes its solar radiation, it will pass through atmosphere and go to Earth. And most of the time, the solar radiation have to be reflected back to the atmosphere, get out of the atmosphere. Unfortunately, we have like a heat blanket covering the atmosphere that trap the solar radiation. So instead of going out, it is turned back down again. All right. So this heat blanket is created by a combination of carbon dioxide and other greenhouse gases. So these gases came from transportation, came from factories where burning of fossil fuels happen. All right. And of course, we have trees. We have trees everywhere in the world, and the natural cycle will be we breathe in oxygen, we let out carbon dioxide, and this carbon dioxide will be taken in by the trees, and then the trees will give us oxygen. However, this natural cycle is disrupted because the rate of carbon dioxide production is faster than the rate of removing it. So we, a human and the factories, we produce a lot of carbon dioxide, and the trees have difficulties to absorb all of them. Okay, because there's not many, I mean, the carbon produced is more than what the trees can absorb in real time. So when we look at the cause of global warming, so when we look at the year 1750, there's no carbon on the atmosphere, or like almost no, almost zero. However, as we reach 1900, suddenly the number of metric tons of carbon per year increases. And now, year 2021, it's up here. Okay, the total of all the gas, liquids, and solid, like the cause of global warming. So what happened here? Okay, what happened here is industrial revolution. So when we have train, we have factories, and all of these are using fossil fuels and burning fossil fuels, burning oils, the carbon increases in the atmosphere. And when we look at the greenhouse gas emissions by sector, okay, so this is for the year 2000. And this report is in year 2005, which is 16 years ago. Okay, and we can see that the carbon, CO2, all of these are greenhouse gases. And when we want to focus on carbon dioxide, okay, 77% is carbon dioxide, and it is produced by transportation, electricity, other vehicle combustion, and we can say that it comes from the energy industry and industrial process. And it's a huge, and from transportation contribute around 13.5%, and all kinds of transportation, from road, from air, from ships. And this is a lot, okay? And when we look at the latest data now, so this is in year 2020, do we see any changes? The transport, the energy sector, instead of 77%, it reduces a bit to 72%, but the industry increases. And then the agriculture and land use increases, and the transport itself increases from 13.3% to 16.32%, which is a lot. So nothing has changed. 16 years has gone by, but nothing has changed, and it got even worse. So how do we tackle global warming? So there's a lot of ways to tackle global warming. So first, we can reduce carbon footprint from using good electrical appliances, and then finding food source from sustainable sources. And then we can plant more trees, of course. We can stop deforestation. We can use renewable energy, such as water and wind, instead of fossil fuels. We can enforce limits on carbon emissions, and this is the role of the government, okay, and the governing bodies. So the UN, they have UNFCCC that that looks at the climate change, and in Europe they have EU commissions that gives rules to factories. Okay, so this is the amount of carbon that you can produce this year, and so on. And in the US, they have US EPA, US Environment Protection Energy. And in Malaysia, we have Ministry of Natural Resources and Environment that controls the rules. And for transport, we can do vehicle sharing, and then we can change our transport to electric and hybrid, and we can use low carbon technology. So this is my topic today. And we as engineers, what we can look at is this three things. So first, reducing electricity for the appliances, and then usage of renewable energy, as well as the transport. Okay, and today I'm looking at this low carbon technology. So what is a low carbon transport technology? And as you guys know, there are three types of vehicles. There's hybrid vehicles, combining electric and natural combustion engine. And then there's fully electric vehicle, so only electric. And also normal cars that is using internal combustion engine, so engines like this. So can we convert all cars to electric vehicles? Is it reliable? Is it realistic? Okay, so when we look at the price of electric vehicles are very, very expensive, especially in Southeast Asia. Not all of us can afford electric vehicles. And then when we look at the infrastructure in Southeast Asia, of course, is not ready at all. In European countries, some of them already have this infrastructure, like to charge your electric vehicles on the highway and so on. However, here we are not ready. So only the developed countries are ready in terms of the infrastructure. And then the technology readiness. So is all electric vehicles good? Some of electric vehicles that are in the market now, like you have to change the battery every 5 years, every 10 years. So the battery itself, the production of the battery is not good. And then the disposal of the battery is another thing. And how much carbon dioxide you really save when you are using electric vehicles? This is a big question, because in order to charge your electric vehicles, you need to, the power comes from somewhere. So the power to charge these electric vehicles comes from a plant. So that plant is burning fossil fuels as well. So instead of having the CO2 being released in the city, what they have done is they have diverted the CO2 production somewhere else, so maybe far away from the city. However, the total carbon dioxide produced is still the same to power up all of these electric vehicles. So do we really save CO2 here? And if we look at automotive council technology in 2012, so this is a roadmap for the UK. So if we look now, we are in year 2021, we are here. So for light duty cycles, for example, cars and van, we can start using electric vehicles. And of course, we can still use normal full fuel as well, natural combustion. However, we can start to use hybrid and fuel cell vehicle electric vehicles. Okay, And if we look at a medium duty cycle vehicle, they can also start using fuel cell and plug-in hybrid. Maybe not full hybrid yet, but plug-in hybrid now, 2021. However, when we look at heavy duty vehicles, for example, big lorries, trucks, they are still relying on internal combustion engine, right? Normal engines. And this will continue up to the year 2050, at least, all right? So there's no running away from internal combustion engine. Okay, this is what this plot is saying. There's no running away from internal combustion engine. So for internal combustion engine, when this is Malaysia ringgit, when I spend 100 ringgit for fuel, how much of the fuel actually used to move the car? All right. So the fuel, 100% of fuel, so some of it goes to exhaust and cooling and mechanical power. So this is our engine. And then from the engine, 32% went for friction losses, and some of it went for air drag, okay, thermodynamic losses. And at the end, the energy used to move the car is only 21.5%. So meaning from 100 ringgit, only 21 ringgit is used to pay the fuel to move the car. So the other 70 ringgit was actually lost in the atmosphere. It's like the carbon that we burn, right? So the movement of the car itself is only 21 ringgit per every 100 ringgit. All right. So the opportunity to improve our engine is actually the other 79%. All right. So if we can improve our engine, it means that we can save more. We can spend more money in order to move the car. Okay. So there's 79% improvement that we can make here. So we are looking at the turbocharger. So why we need turbocharger? Turbocharger is a technology, low carbon transport technology that helps the internal combustion engine to reduce the fuel. All right. So when we look at naturally aspirated engine, so a naturally aspirated engine is the internal combustion engine. So this is the normal engine cylinders, and when you have a turbocharger, you add a turbocharger on top of your internal combustion engine. So how does it work? So instead of, if you don't have this turbocharger, you have air coming into the engine and then you release hot air into the atmosphere. However, when you add a turbocharger, the hot air will go into the turbocharger turbine and it will turn this into a very high speed that will turn the compressor into a very high speed as well, same as the turbine, and it will compress the air intake from the atmosphere. So we can suck more air from the atmosphere and then give denser air into the engine, and the engine can produce more power because of the air being more dense and more volume. All right. And if we look at this video, let me. All right. So I don't think you can hear the volume, but I will talk through this video. So this is a naturally aspirated engine and it is connected to a turbocharger. So the turbocharger consists of a turbine and a compressor. So turbine on one side and compressor in another side. And the turbine is driven by the hot air. Okay. So the hot air, the exhaust gas went into the turbine, and because it is very hot, it creates a very high pressure. So it will turn the turbine at a very high speed, almost 300,000 RPM. And this high speed is translated to via a shaft and turn this compressor. And this compressor turns at the same speed as the turbine, which is very, very high as well. So what it does, it sucks ambient air and send more denser air into air cooler, so it will cool the air to increase more pressure. So this high pressure, very dense air will be sent to the cylinder, engine cylinder, And because of the pressure, because of the dance, it will produce more complete burning. All right, the pressure is higher, so the burning is more complete. Right. So if you have 3 liters, 6 cylinders IC engine, which can produce 200 horsepower, right? When you add a turbocharger, you can, if you want to produce the same horsepower, 200 horsepower, you can reduce the engine size to only 2 liters and 4 cylinders. So instead of 3 times 6, which is 18, you can have only 8 liters engine instead of 18, which is half reduced. Okay, and this is the main point. Okay, so you are reducing the engine size, and what happened is that you are using, because the engine size is reduced, so you are actually using 40% less fuel compared to IC engine. And for diesel engines, you are using 40% less fuel, and for gasoline engines, you are using 20% less of fuel. And of course, because you are using less fuel, then you are reducing the usage of carbon dioxide. Okay. And when we look at turbocharged engine benefit, okay, when we look at in terms of cost saving as well as CO2 reduction, okay, when we say that we reduce 2% of fuel consumption per 100 kilometer. So let's look at the first row here. So average liter is 14. However, if we reduce these 14 liters into 13.72, which is only 2% reduction, we can save fuel up to $61. Okay. However, if we manage to give 6% reduction, we can reduce cost up to $183. So that is a lot. Okay, this is per 100 kilometer. And this is in terms of money, but in terms of carbon dioxide reduction, it can reduce from 129 kilogram up to 386 kilogram of carbon dioxide per 100 kilometer travel. So imagine this transport, after 10 years, it actually save, the owner can actually save up to $2,000, and the carbon dioxide reduction is just below 4,000 kilogram. All right. And this is looking at one type of transport. So if we're looking at the smaller transport, we can see all of this transport will have annual savings in terms of money as well as carbon dioxide. Okay. This is how turbocharger help. So when we look at the turbocharger performance, when we fit a turbocharger into an engine, the engine efficiency, the equation becomes a mechanical efficiency times turbine efficiency times compressor efficiency. And this is a compressor map, so the most efficient part is in the middle, and this is a turbocharger map, turbine map, where this is the highest efficiency is on top. Okay, on top here. So just imagine if we have mechanical efficiency of 0.7 and then turbine efficiency of 0.7 and compressor efficiency of 0.7. So the engine efficiency is 0.7 times 0.7 times 0.7, and we got 0.343. So this is quite a high engine efficiency, because when we look at the previous number, engine efficiency is only 21%. Remember, 21.5%. So if we have a car with engine efficiency of 34%, and imagine if we have the same engine, but we increase the turbine efficiency to only 2 percentage point, which is 0.72, and then we increase the compressor efficiency to 0.72. So what is going to happen to engine efficiency? So the engine efficiency will become, instead of 34.3, it will become 36.28% efficiency. And there's only 2% increase in efficiency of the engine. However, 2% engine efficiency is a lot. Okay, as you can see from this, sorry, I'm just going back here. Okay, with 2% efficiency increase, it will reduce CO2 consumption. It will increase your fuel money saving. All right, so 2% is a lot. Okay, so my work will focus on the turbine efficiency. Okay, how do we increase turbine efficiency? So if we want to have a very good turbine, okay, this is a normal turbine performance. Okay, and if we want a very efficient turbine, we are talking about an ideal case, a turbine with 100% efficiency. But 100% is impossible to get. So it's good if we have a good optimized design that is very close to the ideal case. The peak is very close to ideal case. Okay, and the overall peak, the overall graph is increased as well. So this is what we want to achieve. And now it comes to my project. So my project is about turbocharger turbine optimization, turbocharger design optimization. And there are many ways to optimize turbocharger. So one of the ways is using VGT, a variable geometry turbine, where you have nozzles at the sides of the turbine. And you can also, instead of using just one turbocharger, add another turbocharger. So you will have a multiple stage turbine. So this is another way to increase turbine efficiency. And another way is to make hardware changes. So use a different turbine blade, use a different volute design, so you can increase your turbocharger efficiency. And my project is looking at the third one here. And this project is actually an industrial collaboration project between Imperial College as well as a Caterpillar. So we worked for this project for around 2 years. And we are looking at changing the shape of the turbine blade itself, as well as the ducting, the piping that connect between the two turbines. So when we have two turbochargers, so the high pressure turbine and low pressure turbines, so the connecting piping, the interstage duct. So in this project, we change the shape of the blade as well as the pipe. Okay. So how do we change the turbine blade? So if we look at the traditional way of designing a turbine, so how do we design? So normally engineers, we design turbine in 1D, and then where we look at the flow characteristics. Then the 1D design is translated into 2D, where you are using mainline design, okay, in order to get the 2D shape of the turbine. And then from this 2D shape, it will become a 3D turbine shape. And the designer will use CFD analysis to validate the design, okay, and look at the flow of the air inside the turbine. However, this traditional way is very time consuming because I want to produce a turbine, an optimized turbine shape automatically. So I will use artificial intelligence to obtain this turbine design. So why do I use artificial intelligence? So number one is to replace repetitive human design activities. If I don't choose AI, then I have to use the 1D, 2D, 3D, and then repeat all over again, and then repeat and repeat many times. So instead of doing that repetitively, I use artificial intelligence to do the process for me. And because AI can also help me to do the design in a more systematic way, and of course, more efficient. So what do I need to do in order to use artificial intelligence to optimize turbine design? So first, I have to automate the design process of the turbine, and then I have to choose AI algorithm that is suitable for this work, and I can execute a design optimization algorithm, and lastly, validate my design. So there are many artificial intelligence algorithm. As you know, there's knowledge-based and mathematical-based, and the knowledge-based the one that I'm using will be evolutionary algorithm, specifically genetic algorithm. So this is what I'm using in my design optimization. So what is genetic algorithm? So genetic algorithm or is inside a subset of evolutionary algorithm, and the concept is behind survival of the fittest. So it is very similar to the story of fox and rabbits. So which rabbit will be eaten by the fox? So if we think about it, fast rabbit can run away from the fox, and the slow rabbit will be easier to catch and be eaten by the fox. So the survived rabbit will reproduce and will produce more children, and the children will somehow be stronger than the parents. Okay, and as the generation goes along, we have more rabbits that can survive from being eaten by the fox, and then it will reproduce for new generation. So after maybe 20 generations, the new generation rabbits will be faster and will be smarter. They will know how to run away from the fox. So this is the concept behind genetic algorithm. Okay, so the concept is a heuristics method, which is based on trial and error and based on survival of the fittest. And the genetic algorithm process includes mutation, crossover, and selection, where the process is like in a loop. So in every generation, there will be a crossover mutation process, and it will be inside a loop and until the final generation will get a very high fitness. So this is the background behind genetic algorithm. And I'm using this for my turbine design. So how genetic algorithm work? So this is a very simple example for you guys to understand. So if you have, if you want to design a car, and then you are given a set of wheels, so wheels that cannot turn, wheels that can turn, big wheels, and then you have a box here represents the car body, and then the car body is represented by points like this. All right, so each of these points can move, all right, freely. So when you have to put an objective. So your objective is to get the best car design that can go on this terrain, okay, like this. So when you run GA, so it will look something like this. All right. So over generation, so this is a genetic algorithm will produce a lot of car design, and it will record, okay, which car can go the furthest. All right, so in first generation, the green car can go the furthest. The third generation, the red car can go the furthest, and the process will be repeated until maybe 100 generation. And we can see that the car body shape is evolving to a smaller body shape. And finally, they found like the best car design that can go over the terrain. Okay, let's wait a minute. Okay, that is the best car design. So this car design is developed using genetic algorithm. So the shape is changing every generation. And that is what I'm going to do with my turbocharger turbine. So to automate the design process, I use wheel parameterization. So all the wheels can be generated randomly, and the coordinates can change freely. And the program will automate the mesh generation for CFD, and then it will do the CFD calculation automatically as well. Okay. And after that, it will produce like a full report on the optimized design. Okay, for example, this is my original blade design, and where we have flow separation near the volute tongue. However, when I have optimized the design, I mean the program optimized the design, it will produce a nicer blade design with more curves that will have no separation of flow here. All right. And how do we know, like, how do we get the best turbo design? So the process will be repeated in many generations. All right. So I start with baseline design and go into genetic algorithm. So the program will produce a new turbine geometry and do mesh generation and CFD, and will repeat this loop all over again until I got the best design and the program will end. And for this work, I'm using MATLAB and ANSYS program. And finally, I got the best optimized design. So this is the original blade design. This is the final optimized design. And for interstage duct optimization for the pipe, I'm using the same method as well, genetic algorithm as well. So in the loop, it produces this is using genetic algorithm as well, and it produces a different shape. So this is the original design, and it produces a slightly different shape after the process finish. So we got two new design for turbine as well as for the interstage duct. And after that, because the program, this is in a simulation, all right, so I have to validate this simulation, like whether it's true, this is the best design. So I have to validate it in experiment. So we have to produce all of these parts. So the turbine, the new turbine, we produce the new turbine, we produce the new interstage duct to be fitted on our experimental rig. Okay, and then we put it on the real experimental rig. We manufacture all of the parts and put it on the experimental rig. So this is a special turbocharger test rig in Imperial College London, and the only kind in the world actually, and where we can test our turbine. So this is my interstage duct being tested, and my turbine is inside this volute, right, being tested. And we managed to prove that the design that we have achieved 2.6 percentage increase in efficiency for the turbine and for the interstage duct, right? We have proved the simulation in experiment. And we also did like a detailed flow analysis and do some research why the optimized design is better than the original one, right, for both interstage duct as well as the turbine. And the interstage duct actually went for production, and they have produced this for 10,000 trucks in Caterpillar. Okay, this is the final optimized design. It doesn't look that much different. However, from top, it is not symmetrical anymore, and then it has some dents in the middle. And that is about the project. So I want to encourage like the engineering students, like this is a multidisciplinary engineering areas, okay? So when talking about optimization method, I use artificial intelligence and you need to have skills in programming, of course, and of course computing, like how to integrate between softwares, because I'm using multiple softwares here. And then you need to have calculus skills as well, and thermofluids for computational fluid mechanics. And of course, you need to have basic automotive knowledge as well. And for experiment, you need to know how to do 3D CAD design, engineering drawing, of course, and manufacturing knowledge is very, very important in order to produce all the materials for experiment. And of course, how to choose suitable materials. So this is materials knowledge. And you need to have design precision skills. And for the experiment, you need to have experimental skills, engineering experimental skills. And of course, to build the rig and to read the data, you need sensors and actuators skills. And then you need to have workshop skills and design precision and some lab programming in order to extract the data. And of course, thermofluids knowledge again. So you can see that this one project involves many, many areas in engineering, okay? And of course, lastly, you need engineering ethics in order to like be honest about extracting your data and reporting your result. And for the simulation, you need to have thermofluids knowledge and analytical thinking, as well as calculus knowledge. And you can see that this is my team in Imperial College, and some of us are working with turbine, and some of us are working in compressor, some of us are working in engine modeling and battery and catalyst. So all of these areas are looking into reducing the carbon usage for transports. That is why it's called low carbon transport technology. Okay, that's all for me. Thank you very much.
Thank you very much, Dr. Uswah Khairuddin. Very nice presentation. Let's give an applause, everyone. Thank you very much. All right. That was a nice lecture, by the way, Doctor. I hope all the future engineers can learn. Yeah. We need to learn a lot. As you also show in your degrees that you achieved, you learn various things, and to do your PhD, you know so many different fields, actually. Yeah, so many different fields. Okay, so let's move on to the Q&A session. And currently we already have 2 questions directed to, three questions. But the first 2 questions are directed to Dr. Agnes, Tuti. And the first question comes from ITS, Farid Miftahul Anwar from the Department of Materials Engineering. And his question is, let me try to read it. Okay, so Dr. Tuti, I would like to ask about what we can do to realize SDG or help the government to achieve the SDG as a student. Because I think my government in my village has not understood yet about this topic. Thank you.
Okay. Thank you for the question. From whom? From Miftah. Okay, thank you.
Yeah, from Farid Miftah to Anwar.
From Farid. Yeah. Okay, thank you for the good question. I think, as a student, I think we can do every help people, help the village. Yeah, of course, the village people to improve their knowledge. Yeah, to improve their knowledge, because you already said that the villagers to know about SDG. Yeah, I also said to the Ministry of Village Development before, and I said that the villagers is very difficult to know what is SDG, what is the program, what is how to measure the SDG. As a student, I think you have a better knowledge about SDG, so you can discuss with the village staff, maybe to discuss about the SDG target, the SDG goals, the goals of the SDG, of course. And then if you see one by one goals, from goals number 1 until 18 in village, you can explain what is the meaning of the goals. And I already showed to you that for example, for goals 1, we have many indicators. It means that the indicator is just to measure the achievement of SDG. But if you see the indicator itself, so you can imagine what kind of program can be implemented in the village. Yeah, for example, if you want to make the village have no poverty, have no poor people. So what do you think? What kind of program is related with this target? How to make the poor people can improve the quality of life. So it means that no poor people. For example, in Bali, for example, I already went to Bali sometime go to the village and then ask and discuss with the head of village, kepala desa, yeah. So when I asked to the kepala desa, how many poor people in this village, he said that no poor people in this village. How come they don't have poor people? Yes, because we always help each other. So it means that the poor people can manage by the other villagers. And as student, I think you can also mix the same thing. And if the poor problem is the poverty is because of the lack of knowledge, lack of skill of the villagers, so you can improve. You can help them to improve the skill. Yeah. In ITS, we have a program to improve the skill of the villagers in art. Yeah, from design product in ITS. So the design product researcher can explain to the villagers how to improve the quality of the product. So the value of the product is become more good, yeah, become good, become better after they improve the design, yeah. So make it more creative. Yeah, this is only an example. And also if in village they face a problem in sanitation or water supply, so student can come to the village and help people to have sanitation facilities and help people to have facilities for water, clean water, and so on. Also for waste management and so on. Many things, I think. Okay.
Thank you, Dr. Agnes. So, Mr. Farid, Mas Farid, yeah, Dr. Agnes have mentioned so many examples. What do you think? Is it clear enough? Or would you like to add something to the question, Mas Farid?
I think enough. Thank you.
Thank you. Thank you.
Okay.
So actually, the second question is very related to Agnes. So the next question is from Aulia Uswah Farah Diba from Environmental Engineering IPS. Her question is also for Dr. Agnes Tuti Rumiati. Is there any specific program to accelerate SDG program in Indonesia, especially in village? And then how can we assess the achievement of the program, whether if it is significant or not? That is the question, Aulia.
Yeah.
From Aulia.
This is my opinion, Pak Irfan.
Yeah.
So just I want to show you our program in SDG. This is, for example, to accelerate the improvement of the village. Yeah. Actually, for example, for this village, yeah, we have a research in this village, Selong Belanak area, Selong Belanak beach. Yeah, this is very nice beach. Yeah, this is very nice beach. If you see in front of in this location, there is a very good hotel, but the owner of the hotel is not Indonesian people. And then in front of in this beach, yeah, the Indonesian people is do like this. See, yeah, they have a very small warung, yeah, very small restaurant, and the quality is not good. Yeah, This is for example. So ITS, yeah, our team try to make a planning, master plan to make this village become a desa wisata, yeah, become a tourism village, yeah, and we try to make a design of the beach like this. This is example, yeah. So if the government agree with this design, so if the design is implemented, I think the villager can have a more uh, uh, income, yeah. I think they can improve their quality of services and then get more income, yeah. I'm sure. So that's why we try also to uh, train the villagers to make a good food, and also this is for guest house, yeah, the quality of the guest house, and so on. Also for the promotion, yeah. So this is the example how to improve, yeah, the quality of the village management, starting with the planning, of course. I think if all villages in Indonesia, if you can, as a student, can help all villages in Indonesia to make this, so if they can implement this design, I think the village become much better than now, yeah, than before. So this is more beautiful, and then many tourism, local and maybe international, come to this village and then can improve their income, the income of the villagers. I think this is no, Pak Menteri Tourism, Pak Sandiaga Uno in Indonesia also encourage the village to become a village tourist destination.
Thank
Okay,
you very
Pak.
much. Thank you very much, Bro Agnes, Tuti. So we can contribute, yeah, from university, from ITS, and maybe can help contribute to accelerate.
Yeah, to accelerate and need many discipline, I think, Pak.
Yes, yes.
Yeah, integrated many discipline of our background, yeah.
Thank you. All right. Thank you, Ibu Agnes Tuti. The next question is from Narendra Priyan Pratipta from the Department of Environmental Engineering. But his question is for Dr. Uswah Khairuddin. So is it possible for all internal combustion vehicles to have turbochargers? How long and how expensive will the transition be compared to electric vehicles?
Actually, if you bought a normal internal combustion engine car and then you want to fit your own turbocharger in that car, you can do that. However, the process is not that simple. You cannot just buy the hardware, the turbocharger, and then fit it in your car, and because you need to do fine tuning to match the mapping of the compressor and the turbine, and you have to do a very good matching of the engine and the turbocharger. If not, the turbocharger will not work efficiently, and then it will be just a waste of money. So instead of fitting a turbocharger inside a IC car, it's just better to buy a new car with a turbocharger already fitted inside, because that car will be designed by a turbocharger. And for next production cars, it really depends on the manufacturer whether they want to fit a turbocharger inside all naturally aspirated engine. However, some of the like light transport doesn't need that anymore, because engine technology already become advanced, and the engine size has become very small right now. So not necessarily to fit all IC cars with turbochargers. I think we are looking more at heavy duty trucks and vehicles where they need turbochargers and they are using diesel as well. So turbochargers are more synonym to diesel engines.
Okay, thank you, Dr. Uswah Khairuddin. Mas Narendra, do you have anything or any comments, or would you like to?
No, that is enough. Thank you, Dr. Uswah.
Okay, thank you, Mas Narendra. All right. The next question is actually from one of the speakers, Dr. Uswah Khairuddin. You're asking to Dr. Agnes Tuti. Can I read it? So allow me to read it for you. So, do the Indonesian government ask all universities in Indonesia to have the SDG office and work with the local villagers near the university to achieve the SDG target? Bu Agnes. Bu Agnes, you are still muted, Ibu.
Thank you, Dr. Uswah. Yeah, very good question. Yeah, actually, in Indonesia now, many universities have SDG office. Yeah, many, but this is not compulsory. So this is depend on the university, the need of the university, and now when the university also think that they need SDG office because of the ranking of THE because they want to achieve the good ranking. Yeah. But in Indonesia, Bappenas also accommodate. Yes, the Ministry of National of National Planning also accommodate the SDG from the university. So sometimes they ask us to discuss about the SDG in Indonesia, and also for example, in ITS itself, SDG is not only managed by SDG Center, but also managed by all unit in ITS. Because in ITS, and my understanding, the department also suggests to have a lecture, yeah, about SDG. Yeah, Pak Irfan Shah. I think we not with a special topic, but maybe include in some lecture about SDG. So this is the effort of Indonesia to involve everybody involved to SDG.
I think it's very interesting, like because you have the SDG office, and then you can like do the mapping of SDG straight away with all the departments in the university, and then straight away translate it to activities in the village nearby. And I think that's very good, actually.
Yeah, thank you. Yeah, this is very interesting thing, I think. So we can also have to make collaboration each other in ITS. So in SDG Center, we also collaborate with, for example, Halal Center, yeah, with pusat apa tuh Pak? Energi, ya, pusat studi energi, ya, research center about for energy, for example, and so on. So this is the SDG Center is something like hub of SDG activities in ITS.
Thank you for that explanation, Dr. Agnes Tuti. Yeah, and maybe this model. Through this model, we can maybe share with other partners, universities, and who knows, we can also collaborate.
Yeah. Very welcome. Yeah, maybe we can make collaboration between Indonesia and Malaysia, how to innovate, yeah, make innovation about the SDG. And for Indonesia, this is very interesting if can be implemented in village. because in village level is very difficult, I think, and lack of information, lack of knowledge, lack of skill. This is the problem. So the innovation is related about that.
All right, thank you, thank you. There are still 2 more questions from students, I think. Yeah, both of them are asking questions to Dr. Uswah Khairuddin. The first question from Ilham Febrian Putra, Industrial Mechanical Engineering, ITS. So his question is, in Southeast Asia, cars in here are mainly small engine. There are already turbocharged small engine in the market, for example, Ford EcoBoost engine. But the main problem of turbocharged small engine is sluggish performance, for example, lagging acceleration. The question is, why is this happening? Can those characteristics be changed? Can your AI program fix this problem? So thank you in advance.
Thank you for the interesting question. Yes, actually for all turbocharged engine, we have this condition called turbo lag, where it will, like when you want to increase acceleration, it will have like a moment of lag before it really increase. So if your NA, naturally aspirated engine, doesn't have any turbocharger, it will accelerate straight away. Okay, no lag at all. But for turbocharger, there's turbo lag. And yes, if you do turbocharger design optimization, you can actually change the objective. So instead of increasing the efficiency of the turbine, maybe your objective will be reducing turbo lag. So you can actually design your optimization program to be focused on this objective, and you can reduce the turbo lag itself. Okay, I hope that answers your question.
Okay, Mas Ilham, I hope that answers the questions. Your question.
Yes. That's
okay.
A lot for me. Thank you.
Okay, all right. Thank you for that question. All right, now the next question, and I think it's the last question in the list, from Ravi Vendra Rishika from the Informatics Department. So the question to Dr. Uswah Khairuddin, so good afternoon, excuse me. I want to ask questions to Dr. Uswah Khairuddin. Number 1, how many iterations did you need in the journey to get the best machine design based on genetic algorithm? Secondly, besides of the change of design, is it possible or is there any research to change the component of the machine to maximize the efficiency? So for example, using aluminium instead of steel. So those are the 2 questions.
Right, thank you very much. So for your first question, like how many iterations? So for the interstage duct as well as the turbine, I have different number of iterations, and it's mainly dependent on the machine that I'm using for the calculation, because we are using 3D CFD optimization. So in every iteration of genetic algorithm, there will be a 3D CFD calculation. So there's parameterization, and then mesh generation, and then CFD calculation. And for turbine blade, we can reduce the calculation timing when we did a simulation on a single blade design only. So we reduce it to a single blade flow. So we can change design of a single blade and just multiply it by 12 blades, for example. And because of a reduction of that simulation, what do you call it, module, we can increase the iterations up to 1000. All right, it doesn't matter because each iteration only took 4 minutes to run. And for the interstage duct, it took a bit longer because you need to, the whole CFD domain, the whole turbocharger domain to be there inside the calculation. So the simulation took a very long time. So one iteration will take around 7 hours. So I reduced the number of iteration up to 100 maximum. And we actually stop when we feel that the efficiency reach increase up to 2 points, because it is very hard for the efficiency to increase 1 point or 1.2 points. So when it reaches 2-point efficiency, we stop. However, this can change if you have a better machines. In the future, of course, the computer will be faster. And in my case, I was using a parallel high performance computer, which is a servers outside the office itself. So we are using a centralized high performance computer in Imperial College, and I'm using at most is 40 CPU at a time, and that already took 7 hours. And if we have better machines in the future, of course, you can increase the timing. Okay. And the second question, I'm sorry, what is the second question?
So it was about besides the change of design, is it possible or any research that you've done
about
to
the
change
material.
the component, the component
Yeah.
or the material, to maximize the efficiency?
Yes, of course, you can change the components, the materials. For example, the turbine blade is made of aluminium, and if you have a lighter material, maybe that you can use, it will be good because you can increase the speed of the turbine. However, you have to make sure that the new material can withstand the temperature of the hot air going inside the turbine. It's very, very hot. And that will be another research. The material will be another research, and then you can do simulation and as well as experiment to validate your simulation. Thank you.
All right, thank you for the answer, Dr. Uswah Khairuddin. So there it is, Mr. Ravi Vendra.
Yeah,
do
absolutely.
you have any more things to ask?
Thanks for the answer. It is a complete answer, and I think it's enough. Thank you.
Okay, that's good. Thank you very much, Mas Ravi. Thank you. Yep. So I think that concludes our Q&A sessions, and let's give an applause to both speakers, Dr. Agnes Tuti Rumiati and Dr. Uswah Khairuddin, for the very insightful presentations today. Very interesting talk. It was a pleasure to be in this session and listening to all the presenters here today. And I think that's it from myself. I would like to apologize for how I bring this sessions, and then I will give the session back to the MC. Thank you.
Yeah, thank you so much, Dr. Irfan, for moderating the session today. And of course, thank you very much to Dr. Tuti and Dr. Uswah for the excellent lecture today. Please give applause to our speaker and moderator by using the Zoom reaction feature. All right, thank you, everyone. And we would like to present a certificate awarding to our speaker and also our moderator today. Okay, the first is certificate to Dr. Agnes Tuti Rumiati.
Thank you.
And the next is certificate to Dr. Uswah Khairuddin. Yeah. And the next certificate to Dr. Irfan. Yeah, once again, thank you very much to Dr. Tuti, Dr. Uswah, and Dr. Irfan for the availability on today's guest lecture series. And I believe that all the audience had more insights about the SDG number 11, about sustainable cities and communities. Okay, now before we end our lecture today, we invite all participants as well as the honorable speaker and moderator to take a group photo. To all participants, please open your camera and get yourself ready. Yeah. I think I will take twice, so please keep smiling until we finish the photo session. I will start counting. 1, 2, 3, Okay, one more time. 1, 2, 3. Okay, now we have finished the group photo. And for participants, please fill the feedback form through the link bit.ly/feedback_GLS that you can also see on the Zoom chat room. The feedback form will be closed 1 hour after we finish this session. So we want to remind you that the participants who will get the stamp and certificate are those who come on time, join this event until the end, and also fill the feedback form. So be sure that you not miss the feedback form. And lastly, before we end the session, I would like to remind you about the upcoming guest lecture series on SDG. This is the poster for next week series. We will have SDG number 3, and we will have Associate Professor Normaizatul Akmar from UNIMAP, and also Dr. Indah Muhammad Amin from University Technology Mara. And the other stream, we will have Professor Porferia Poralan and Dr. Natiara Muhammad Hashim from University Technology Mara. We will have the same session as today at the same time. So you can mark your agenda and join the event next week. Okay, finally, we have reached the end of today's guest lecture series, and we sincerely apologize for any mistake we have made in presenting as Master of Ceremony and also as committee. Thank you very much to our honorable speakers, moderator, and all participants for the attention and cooperation. We hope to see you again in our events in the future. And don't forget to follow our social media on Instagram at ITS International Office and keep update to our programs. Once again, thank you very much. Good afternoon and wassalamualaikum warahmatullahi wabarakatuh.
Thank you. Bye.
Waalaikumsalam.
Thank
you,
you.
Dr. Uswah Khairuddin.
Thank you.
Terima kasih, Mbak Miss Tuti. Thank you very much, Bu.